Hi everybody. Last week we talked about radioactive dating, and you did that experiment with the pennies or the coins, and hopefully that worked out well for you. This week I want to focus on geologic time periods, and the sequence of events for the Earth from its formation to current time. So we'll take a look at geologic time this week. After this week, we'll probably start moving toward astronomy, and we'll talk about that when we get to it. But let's get into some geologic time. So, geologists have a way of recording geologic time. They use essentially their own calendar. We use months, years, weeks, and so on, days and hours and whatnot. With geology, because we're dealing with such large blocks of time, those traditional units of time are not very useful. Years, hundreds of years even, let alone hours and days, just are not that useful because we're talking about huge amounts of time. So we can divide geologic time into larger chunks, and we could divide geologic time into what are called eons, eras, periods, and epochs. Most of you have probably heard of the Jurassic period because of the movies and the book, and it's well known for the dinosaurs and so on. But there were many different geologic time periods, and we'll take a look at those. And again, a geologic period is only one way of looking at time. To put this in some perspective, and we'll look at a chart that organizes this. This is similar to the way that we keep track of time, but with geologic time, we're talking about millions, hundreds of millions of years, or in some cases, billions of years. But an eon in a human construct might be similar to, say, something like a decade. Or maybe, let's scratch that out, let's make that a century. So when you're in social studies and you're learning about different centuries, the 1700s, the 1600s, and so on, we sometimes look at human history in the century. Eras would probably be more similar to our idea of a decade. Periods might be more similar to a year, and epochs might be similar to months in human time. So the geologic time scale, going from eons to epochs, gives us a way of just sort of breaking down time into chunks. So an eon represents more time than an era, just like a century represents more time than a decade. A period represents more time than an epoch. It's just basically a way of dividing up the time. And we'll take a look at a chart in your reference table that'll hopefully make that a little clearer. The boundaries between different time periods or eons, eras, and epochs, and so on, have to do with major changes on Earth. So these major changes could be mass extinctions. Mass extinctions often define the end of one period and the beginning of another geologically. So mass extinctions, and everybody knows about the mass extinctions of the dinosaurs, but there were other mass extinction events in Earth's history. Dinosaurs just tend to get the most attention. Changes in landforms. The position of the continents. This little arrow, by the way, was supposed to be up here. And what this little arrow is basically showing is that eon represents the longest amount of time, and the epoch the shortest. Just like a century represents more time than a month. Okay, that's just in the wrong place. Anyway, these boundaries between these geologic time periods and eons and epochs and so on are defined by major changes in Earth, changes in climate. I'll say changes in life. When the first fish appeared and so on. Volcanic eruptions. So major changes on the planet determine when one period ends and another begins. And to the best of our knowledge, using the radioactive dating concepts from the week before, the oldest rocks that have been found, and we can infer from that radioactive dating process the age of the Earth to be 4,600 million years old. Or another way of saying it is 4.6 billion. Same thing. So let's take a look at the reference table. If you have your reference table at home, you could get it out. You could always print one out too if you have a printer at home. And you could just go to Google and type in New York State Earth Science Reference Table. Now, to start out with, let's go to page 8. So here's page 8 in the reference table. And this is going to be a little hard to look at. I always find this part a little frustrating because this chart is designed to be looked at as 2 pages at the same time. So we have page 8 over here, and we can see there's a lot of information in there. And then if I slide over, here's page 9. It's all the same chart. It's all the same geologic timeline, just split up onto 2 separate pages. So when you first look at this, it might be a little overwhelming. A lot of information here, all kind of crammed in. Let's start out with page 8, but just remember that page 9 is a continuation of page 8. And it's a little hard, especially when it's just a stapled packet, to really have them side by side. If it were like a book, it would be a little bit easier, I think. But anyway, let's go to page 8. So if we look at page 8, and let's take a look at geologic time to start, we can see those units of time that we were just talking about. We have eons, eras, periods, and epochs. And in this column in the chart, it's describing major changes in life on Earth. For example, here we have humans, mastodons, and mammoths coexisting. There's a lot of evidence to suggest humans were hunting mastodons and mammoths in prehistory. If we go back, we can see different creatures, dinosaurs, and fish, and eurypterids, and trilobites, and whatnot. Where this chart can get a little confusing, and where sometimes students have trouble interpreting it, is with these columns for eon, era, period, especially. So why don't we start there? Now, our largest unit of time is the eon. So why don't we begin with that? I'm just going to take this paper and cover that up so we're only looking at the eon. Well, the eon is our largest unit of time. It's similar to, say, a century, or even bigger, really. We have this period of time, or this eon of time, called the Precambrian. And the Precambrian time can be subdivided into what was called Archean, which is older. Here's that 4,600 million years ago. This represents the formation of planet Earth. And then the Precambrian lasted all the way up until probably like around 540 million years ago or so. But the Precambrian represents all of this time here, and it can be divided into Archean and Proterozoic. Once we get out of the Precambrian, we're into what's called the Phanerozoic eon. The Precambrian represents a large portion of Earth's history, probably about 90%, and we know very little about what happened at that time. That was so long ago, we don't really have fossils. We have no record of life for the Precambrian. I'll make a note of that. No record of life. So we have no record of life, no fossils, no evidence of life for the Precambrian. Which brings us to the Phanerozoic. And this means that all of the life that you can imagine, trilobites, dinosaurs, eurypterids, and everything, existed in the Phanerozoic. So most of what we know about is in the Phanerozoic eon, which is actually a lot. We have a lot of fossils, and we know quite a bit. It's an incomplete picture, but we still know a lot. So if we look at the Phanerozoic now, and we spread out into the eras, where sometimes this can be a little confusing, is the eras. We have Cenozoic, Mesozoic, Paleozoic, but these three eras are all being squeezed into this little bit of Phanerozoic up here. So actually the rest of this chart is basically all getting smushed into this little Phanerozoic corner. We really don't know too much about the Precambrian, and most of our knowledge is in the Phanerozoic eon. So most of this chart is getting compressed and squeezed down into this little area at the beginning of the chart. So if we look at the era, we have the Paleozoic, Mesozoic, and Cenozoic. Paleo means old. So Paleozoic time is basically ancient time. Meso means middle. The dinosaurs existed during the Mesozoic, and that basically defines that era. The Mesozoic is the time of the dinosaurs. Cenozoic is really the time of mammals. We live in the Cenozoic, and the Cenozoic is continuing on today as time keeps ticking on. Then we get to the periods. This is maybe a little more familiar to some of you. With the periods, now we can take the eras and we can split them up into periods. If we come down to the Mesozoic, this is the time of the dinosaur. Well, everybody knows Jurassic period. But the dinosaurs also existed in the Triassic and the Cretaceous throughout all of the Mesozoic. So they weren't only in the Jurassic, they were also in the Triassic and Cretaceous. At the end of the Cretaceous period, the dinosaurs went extinct, mammals became more dominant, and dominated the Cenozoic. And we could divide the Cenozoic into these three time periods here: Quaternary, Neogene, Paleogene, and so on. If we come down here, Paleozoic, this is old time. Now we have some very old time periods, starting at the Cambrian. The Cambrian represents the formation of life on Earth. Sometimes people refer to this as the Cambrian explosion. This is when life really takes off on Earth. Then we have Ordovician, Silurian, Devonian, Carboniferous, which gets split up into Pennsylvanian and Mississippian, Permian, and then that's the end of the Paleozoic. Now we're back into Triassic, formation of dinosaurs, Jurassic, Cretaceous, extinction of dinosaurs, and now we're into age of the mammals. So if we take a look at a couple of other things here, here we have the major changes in life on Earth in the next column. It says life on Earth. Now, if we look at the Cambrian, we have diverse soft-bodied organisms. These were some of the first creatures to evolve on Earth. And here I have one of these little creature tubes. Some of you might have seen these before. They sell them in gift shops at museums. In fact, I thought about buying this at a museum and then didn't. And then my wife bought it for me as a present, which was a nice little thing. But anyway, here we have Cambrian life creature tube. They make these tubes for all kinds of things like African mammals and stuff like that. But the Cambrian one is kind of interesting because not many people are very interested in the Cambrian time period, which probably isn't very surprising. But if we take a look at it, what's kind of interesting about these creatures is they were soft-bodied. They were all marine creatures. They lived on the seafloor. We have early sponges and invertebrates, soft-bodied organisms, poor fossilization, but some of them were preserved. This one, very interesting creature, used to swim in the water. It was a predator, and it had these kind of like grabbers on the front and like a sucker mouth where it would catch its prey. And these actually, I think, got to fairly large sizes. Here we have a very primitive worm, some early trilobites, and soft-bodied organisms. Okay, not well represented in the fossil record, but these are all creatures that existed during Cambrian time. In the next video, we'll take a look at these other time periods and some of the major changes that occurred, and we'll look at how to use this chart in a little more detail. But again, if we go back here, Precambrian represents most of Earth history, and we have no record of life for the Precambrian. Okay, so we'll work on this more in the next video.